Greetings. In today's lecture, I'm going to discuss about three equivalent forms of a quadratic function. The standard form, the vertex form, and the factor form. And also discuss about benefit of each of them in interpreting the graphs, the corresponding graph. Now, in a live class, I always give a background preparation, refreshment if that topic has already been mentioned in the past, part of it, and if it is not, I give the background preparation with the supplementary notes or go over them in the class so that the student know exactly what you are talking and the background that they need. So here I start with your permission with the polynomial, what polynomial is. Now I have written this for those students that they like to take notes because I'm assuming that I'm in a live class in the class. Now polynomial, I have already checked and I have written them large enough so that I suppose I don't have to zoom them all in so that they become larger. I could do that. I have access to my camcorder. Now here polynomial is an expression in this form. an x to the n, an minus 1, x to the n minus 1. An means is a coefficient, numerical coefficient that goes with this particular x of this power. That's what we call it, a to the n, x to the n. Now here, an minus 1, the coefficient are numbers. They can be real or complex, and n is a non-negative integer, which means it is 0, 1, 2, 3, and so on, whole numbers. Now, the polynomial expression comes in the form of equation, or they come in the form of functions. And they have tremendous amount of application, both in pure mathematics and applied mathematics. All branches of science. It's extremely important subject. Now, when the polynomial is given as an equation, the solution of that is finite. And the solution of that, if it is degree n, let's say if it is n is 10, let's say, there will be 10 solution. What does solution mean? Means the values that we put for x, for those numbers, will satisfy this equation. And if the n is 10, so there will be 10 of them, but they do not have all to be distinct. Do you follow me? Now, number one question to ask is not just fast. How do you know that this will have a solution to begin with before you said that there are 10 of them? What guarantee to give me that such a value for x does exist before I go and try to find it? Now, it's a very good question. The answer is the fundamental theorem of algebra. The fundamental theorem, which is a theorem, has been deductively proven. It is proven, so we cannot question it, we cannot give any counterexample. It guarantees that there will be answer, but it does not tell you how to find it. And how to find those values of x that will satisfy this equation is an art of algebraic manipulation. As a matter of fact, sometimes you cannot find it exactly, but you can get as close to that value as you wish, especially with the advance of technology we have nowadays. Now, this, if polynomial, we write it in the function form. This is called polynomial of degree, in the function form, when we write it like that, this will be polynomial function. All right. Now the difference is that this x will have, as I already mentioned, a finite number of values that can assume for x that will satisfy this equation. But this is not the case for here. The values that x can assume, according to the domain of the function, is infinitely many, is not finite. That is one difference. And that is the reason we call them variable. So I do not like to call x here as a variable. I call this one unknown, because certain numbers only. Now the values that we select here for x from the domain can be random. We can select one number randomly and evaluate the value of y. But that is not what we can do here. So there is a big difference between them. And I repeat one more time, x here we call it variable because it can assume different values. We can assign different values for x. Here we cannot. So we call this x as unknown. And with algebraic manipulation, we try to know what is that value of unknown. So that is the two differences. Now, let me go to polynomial functions of degree 2, which is called quadratic function, and interpret that one. Now, quadratic functions, let me hang this one up. Now, I have written again for those of you who like to take notes. Polynomial functions of degree 2, I also read it for you if I may, are called quadratic functions. This is a very popular name for them. And they may appear in 3 different forms. They may appear 3 different forms. And those forms are, we can have them to be equivalent. We go over that. One of them, it may appear in this form, ax squared plus bx plus c, which is, we call it a standard form. It may appear in the form of ax plus or minus b squared plus c, we call it vertex form, or it may appear in this form, a times x minus b x minus c, which is a factor form. And each of these forms have its own benefit interpreting the graph. We go over that. Are you with me so far? Okay, let's now discuss each of them and seek for some good examples to go over. Now, this is, I'm giving an example of a quadratic function in a standard form, all right? And I want to discuss the possible appearance of that mentally. I want to discuss the possible appearance of the graph of that mentally. This standard form does help me quite a lot. Now, how I do that is that when x assumes very huge number, let's say 10 to the 10, which is very big number, then x squared will be 10 to the 10 squared, which is much larger than 10 to the 10. So 10 to the 10, comparing to 10 to the 10 squared, looks like a drop in the ocean. That if you take it out of ocean or add it in the ocean, it doesn't make any difference really to the ocean. And the number 6 will be a joke. It's so small comparing to that. So this first term, in this case, will be the dominant terms when x is extremely large. And that means, and the graph of negative 2x squared is the graph of a problem that opens downward and what? and, and has a maximum point because opening downward. So this is the mental interpretation of the picture by analyzing the standard form of that. So now we go to other forms to help us, to assist us to sketch the graph of that, to find the better points on the graph to sketch. Are you with me so far? Now, we want now next to convert, excuse me. Now we want to convert a standard form of a polynomial, of a quadratic function into, let's say, vertex form, and see what is the advantage of that one as far as the graphing is concerned, the interpreting the graph. Now here, now in order to convert a standard form into a vertex form, we have to go over completing a square. And students are already at this stage of the course are already familiar with quadratic formula, and the quadratic formula is derived from completing a square. As a matter of fact, I have a full lecture in my channel about that subject. I go dive deep into that, where they come and how they come and why they work that way. So they are familiar with completing a square, but completing a square is a little bit tricky, especially for a beginner student. Freshman in basic algebra and developmental mathematics student have some difficulties with that. So I'm going to go over that as a side in a sense, and then come back to this one. Now, what is the completing a square? So I made this example, x plus b quantity squared, which is a complete square, is equal to x squared plus 2bx plus b squared. We are all familiar with that, huh? Okay. Now, what do you notice? I'm asking the students. What do you notice between the b of the third term, in this case, and the coefficient of x of the second term in this case? You see what I'm saying? In this case, because addition is commutative, I don't have to write it in this form. But for the sake of discipline, almost all textbooks, they write it in descending power of x when they want to discuss polynomial. But you don't have to do it. Okay, what do you notice? Now I gave in a live class about, let's say, 15 seconds, half a minute for a student to think. And I give bonus point for them in case if they answered the question. Now if they didn't, then I go over that myself. So I noticed that this b is half of the coefficient of x, because half of the 2b is b squared. That means if this is missing, I can always, from the coefficient of x, find it. I take the coefficient of x, half of it, square it, and add in there. So I have the third term. From this, what I'm familiar with. So I made a, in a sense, discovery for today. Now, I have written here, half of the 2b squared, which is b squared. Okay, now we want to go, let's make a good example for this one. Completely squared, again, I repeat myself, is a little bit tricky. Students do have problem there. Experienced teacher is fully aware of that. So experience comes a lot to be better, effective teacher. Okay, here we want to convert this x squared plus 2bx, we want to convert that one into its equivalent form of completing a square. I repeat myself, equivalent forms, which means the appearance of the coming answer may look different than this, but it is there. Just some cosmetic makeup I have put on it. All right? Now, what do I do here? I have gone over that. I take this one, I take half of the coefficient of x, which is what? Which is b. Square it is b square and add in there. Now I have a complete square. But not so fast. Not so fast. I have no permission whatsoever what is given to me to change it. I want to find something that is equivalent to this. So in order to compensate with the b squared that I added there, I also subtract another b squared from that. In other words, I take half of the coefficient of x term, the term that has x, half of it, square it, add and subtract. For example, if the coefficient of x is 3, half of the 3 is 3 half, square it, which is 9/4, add 9/4, subtract 9/4. So in reality, I'm adding 0 to this part, to this expression, to this original expression. And 0 is identity element for addition, which means adding 0 to a number, the identity of that number is not changed. That is the reason they call it identity element. Additive identity, they call it. So I'm adding a reality, again, I repeat myself, a 0 in that. I take half of the coefficient of x, square it, add and subtract, and look what happens. The first 3 terms, I said add and subtract. I didn't say subtract and add, remember that. I add and subtract. The first 3 terms always give me a complete square, which is x plus b quantity square. And then this stays same. Now, in order to make sure that I have not made mistake, I can go ahead and expand this one. I get this one. This and this, they cancel each other. Hey, hooray, I came out with the same that I started with. Now look at this one. This and this, they look so different in appearance, but they are exactly the same thing. That's the beauty of algebra. Abracadabra. Okay, now let me go over the converting. Now let me see, I have 5 and one of them I'm missing. Before I go that, excuse me, let me see where I put it. Here it is. My apology. Okay, now I go to converting the following quadratic function to its equivalent form in vertex form, and then see what is the benefit of having that form of that. So we have a standard form, we want to convert it into vertex form. Let's see, the completing square comes into the picture. Now, minus 2x squared plus 4x plus 6 is my standard form. So what I do, I write it in this form. First, I factor -2 odd. So all of them, fortunately, they do have that -2. I factor it odd, and I write it in this form. And I wrote here, why? Why do you take -2 odd? I'll come back to that. Now, after I took that one out, then I go and start to complete the square. Now, what I do in class, is that my students are also aware of that. I make the same mistake that students make and pretend that I didn't do it purposely, and see if a student notices it. If they do, I give them bonus point. If they don't, then I go and look at it and see, hey, it looks like there is a mistake, and try to find it. Now, the mistake that most students do make, again, an experienced teacher is aware of that, is that when the quadratic function is given in a standard form like this, they take half of the coefficient of x, which is 4, which is 2, then square it, which is 4, add and subtract, as I have mentioned in completing a square, and they think that here it is the complete square. And I do the same thing, and I end up with a very some expression. Then I look like it doesn't look like right. So I go backward, and I see I don't get the same thing back. So I didn't make any equivalent form of it. So I say, hey, what happened? Then I say back, what happened? When I was completing a square, I noticed that the coefficient of x squared was 1. So the coefficient of x squared must be 1 to begin with before you start completing a square. What about if it is not 1, as this is the case? In this case is -2. If it is not 1, then factor it out. Make it 1. That's abracadabra beauty of the algebraic manipulation. So I factor -2 out. All right? Now, look at what I did. I left a room here. You notice that one is large enough. Hopefully for you, I can even zoom it. I left here a space here to have room for taking half of the coefficient of x, square it, add, and subtract. Half of the -2 is what? Is -1. Square it, you get +1. Add +1, subtract subtract 1. So 1 square, 1 square, 1 square is 1. So it's 1 minus 1. Again, I repeat myself, you are adding 0 in there, so you're not changing anything. So when you do that, you get what? You get the x minus 1 square minus 4. Now you want to write it in a perfect square. Is that a complete square? So I write it in this form, and -2, don't forget when we bring -4 out, there is a factor in there that should be multiplied. That is another common mistake that majority of freshman students make. So they forget about this -2, and they write it in the form of -2x minus 2 squared, what? -4. And they complete the square. So I do make that mistake, again purposely, and then I work backward, and I see that when I do that, I do not get this one back. Say, hey, not so fast, what happened? I am changing the appearance of that to a vertex form, and I already mentioned how vertex form looks like. Let me bring it up if I have it. No. This was the vertex form that I begin with. I want to make that one in this form, the appearance of that. So when I work backward, I notice that I do not get this one back. So hey, there is a mistake. Then I come back and see if a student can help me to find that mistake, and we end up that we didn't multiply -2 by -4 before we write we took the -4 out without multiplying by -2 as a factor. Again, that is a common mistake they make. Okay, now what is the benefit of this now? The benefit of vertex. Now let me go to the general form of it again, and I put it back. Okay, let's see what is the benefit of that. In this case, I can say. Now, the benefit of that, let me do it in general rather than this particular example. Now, the benefit of the vertex form is a transformation of the graph. Transformation of the graph, because we have transformation of rigid and non-rigid transformation, and we have rigid transformation is like reflection, translation, and the transformation of the graph. And I have a complete lecture about that using absolute value in my channel. You're welcome to watch that. Now here we are concentrating on that. Now here the B tells that first we put the graph in a standard form, which in this case is opening downward. The graph, my function is opening downward, so I put it in the vertex to be at the origin. All right, and then this B tells us the graph should move right or left. All right. If we have a negative here, the graph will go to the right. If it is positive, the graph will go to the left. And I hate to say that one. Unfortunately, I've seen in YouTube many teachers that they lecture, they do say that. And that is absolutely false, absolutely wrong. It's not false, but wrong. Why is it wrong? Because the students were arguing one time in the cafeteria, and one of them said that the question was x minus 2, let's say, square, and plus 5. Then he says that we move it, because it's negative, we have to move it to the left. Then the other student said, no, I think the teacher said if it is negative, you go to the right. The other one said it doesn't make sense. Negative means you have to go to the left. Then the second one asked the other student, hey, John, if it is negative, you go to the left or you go to the right? And John says, well, I'm not sure. But then the other one again comes and changes their mind and says, negative, you must go to the left. That's common sense. You see, this is mechanical and wrong way of learning, a mechanical and wrong way of teaching. So it's not that a game of going left and right. If it is negative, you go to the left or you go to the right. There is reason behind that, how you do and how to interpret that one. And I have a complete lecture about this in my channel. Why you go to the left, why you go to the right, why you go up, why you go down, etc., etc. This is mathematics, it's a critical thinking. It's not a recipe following and a mechanical approach. Now here, so the sign for B tells us how the graph is moving left or right, and C will tell us how the graph is going, what it goes up or down. And the coefficient A here, if it is positive, has a minimum point, opens upward, and if it is negative, opens downward. If it is bigger than 1, the graph will be a little bit skinnier than the mother graph or parent's graph. Parent's graph of y equal to x squared, let's say, will be inside that. And if it is between 0 and 1, like 1/2, is a little bit wider, which means the parent graph of y equal to x squared, let's say, will be inside that one. So that is a big advantage of knowing the vertex form of what? Of a quadratic function. How much help he give us, mental picture of that, and also sketching the graph. Now, the final part is to discuss about factor form of a quadratic function, and what advantage that one has, and what benefit that can give us to us. So here we want to convert the given quadratic function into its equivalent form in factor form, and see what advantage that gives to us. So again, the given function is negative 2x squared plus 4x plus 6. So we first factor what they all have in common, which is negative 2. And then this one, we either use quadratic formula x minus, and find the root and put it there, or trial and error, and find out that we can write this one into this factor form, this one. So the final answer will be y equals f of x minus 2x plus 1, x minus 3. Now the advantage of this form is that he shows us the x-intercept and he shows us the y-intercept. So the x and y-intercept becomes very clear to us, become crystal clear for us in a sense. Now, What is the y-intercept when x is 0? You put for x 0, you find what is the y-intercept. And what is x-intercept when y is 0? And you go for this, and when y is 0, what will be the value of x? So you can find the value of x hitting the x-axis. Okay then, I hope that this lecture was beneficial to you, and there is a lot more into that, and I thank you for watching, and I wish you all, as always, prosperity and good health, and please stay safe. So long.